So what happens when we work with numbers greater than base 10? Well, let's take a look at the base 10 setup a second. All of these right now have the numbers 1 through 9 in them, and that's perfectly great because they all do. And they all will continue to have them. But let's look just at base 10 a second. And what happens when we reach after the number 9? Naturally, our gut then goes 10 because the ones digit is restarting. And we put the 1 in front to signify that we've made one whole cycle through the ones column. Well, essentially, we're doing the exact same thing with other bases as well. Except for one thing. The 0 in base 10 has to indicate that's our reset point. And the number in front can still be the amount of cycles that goes through. So in base 11, 10 will occur, but it will occur at the 11th position. So 10 will occur still, so there is something that goes in between. And that something is your other friends from kindergarten, the alphabet. So we start using the letter A to get us to that point where the 0 can show up again. So take a look. The 9's here. This is 11 because 0 means we've made it through the whole way through. And we're ready to restart again. So 1 here means we've made it through an entire cycle. So the A takes the position of the number 10. So what do you suppose would happen then for the number 12? Because we're going to have 2 spots in between before we reach the number 10 again. And if you guessed the letter A and then the letter B, you would be correct. So for 13, it's A, B, C, 10. And base 14, A, B, C, D, 10. How about for base 15? Yep, A, B, C, D, E, 10. And then base 16, which is our hexadecimal color chart base number for the different colors, which we'll talk about in the next slide. The specifics of that would be A, B, C, D, E, F, 10. That's where it stops. That 10, once again, represents once you made it through all the way to the 16th round of the ones digit, the 0 resets, and the 1 recognizes that you've made it through an entire cycle one time. So, mathematically, we can go then all the way to base 36, which would do 1 through 9, then go A through Z, then A through Z, before you ever reach the number 10, because of how large the cycle would be for a base 36 number. So what makes up these hexadecimal numbers that give us the colors? Well, let's take a look first at the 3 colors that a computer monitor recognizes. These 3 colors are red, green, and blue. Those are the 3 colors that all of your televisions, computer monitors, video games, etc. recognize as the color combinations that make up everything. So if we work in Photoshop, for example, and you click on a particular pixel, the program will detect the amount of red, green, and blue is used to make up that color. Now, since we have 3 colors, but hex codes have 6 digits, then each hex code is comprised of 2 spots for that color. So the first two are red, how much red is present. The second number is how much green is present. So the second set of numbers is how much green is present. And the third is the amount of blue. So think back to our number line a second about which number would be one of the highest. It would either be E, F, or 0 would be representing a high amount of that particular number. So take a look real quick at our hex code chart here. Let's look at the red first. You see how high these bright red numbers are in row 6, column 1 and 2? They're up in the F's with very little green or blue involved. The little darker shade of red here has a little bit more green and blue. So that's telling us that the first two digits are the red. Take a look at the green. How high the numbers are with the letter F's in the green. And then those would be the middle two numbers that represent the amount of green in a color. Then take a look at blue. Lots of F's in the last two digits of the blue colors. That means a lot of blue is present. Notice how the darker the shade, the lower the numbers are. Because think back to your art classes. Black is the absence of any color, and white is the inclusion of all color. So the lower the numbers are, the less of that particular color is present. So the blues are missing, for the most part, red. Have a little bit of green in it, but the blue's the strongest. Red is missing mostly blue and has a little bit of green. Green is missing a lot of red, but has a little bit of blue to mix into it. Depends on the shade that we're looking at. So all these three colors combine together, not just to make these, but if you look up a hexadecimal code chart for colors, you're going to see a very wide range available. In addition, the range that the red, green, and blue can be present ranges anywhere from 0 to 255. So the higher the number, the more is present. If all three of these are 255, then we have the color white. So there could be from 0 to 255 present in red, 0 to 255 present in green, or 0 to 255 present in blue.